We are going to discuss now chemical kinetics. In this topic, chemical kinetics, we are going to discuss about introduction to chemical kinetics, rate of a reaction, variation of concentration with time, rate loss, rate constant, and specific reaction rate. Followed by some more topics are there. First, let us start with the introduction of chemical kinetics. What is chemical kinetics? In that term itself is very clear that it is about kinetics. What is the meaning of kinetics? Kinetics is representing the word called speed of the reaction or rate of the reaction. The speed of the reaction or rate of the reaction study is called as chemical kinetics. Chemical kinetics is a branch of chemistry which deals with the rate of reaction or speed of reaction. That's what chemical kinetics is. And chemical kinetics, that means it is going to tell you the speed or rate of the reaction. So, in this chemical kinetics, not only speed or rate of the reaction, along with that, we also will be studying about conditions which favors the rate of reaction. Conditions which favors the rate of reaction also will be discussed here. What type of conditions? The conditions can be concentration, temperature, catalyst, pressure, and so many factors that will be studied separately in our syllabus. So, this is what the introduction of chemical kinetics. So, here we are going to study about rate and which conditions are favorable and what are the conditions, how they are favorable. Now, looking into the rate of reaction. So, what is the meaning of rate of a reaction? This also can be called as a speed of a reaction. What is the meaning of rate of reaction? Rate of reaction is the reaction in which the change of concentration with respect to time. Their rate of reaction is the reaction in which the concentration, how it is varying with time, is represented by a rate of reaction. For example, if you are considering a reaction from reactant to products, imagine this as reactants and these are products, right? And how the reactants are going to be converted into products, that concentration that is means change of concentration of reactants or products with respect to time is called as rate. So rate is equal to change of concentration with respect to time in unit time. We can call it as d change of concentration by d change of time. That is called rate. How the rate is changing. And now, first of all, what is this concentration? We have to know each and every term very clearly here. What is the meaning of concentration? Concentration means expression of any component in some units. So, components will be expressed in terms of mole per liter. Mole per liter is the concentration expression, that is, we will express in terms of mole per liter, that is concentration. Obviously, time we will know, we will express in terms of seconds. That means, what is this rate of a reaction? Rate of a reaction is the expression which is indicating the change of concentration with time. Now, if you are looking into this carefully, for example, at time t1, imagine the reactants are R1 and the products are P1. After time, some time, that is time 2, T2, the reactants became R2 and the products became P2. Now, in general, we can change it as delta T is equal to T2 minus T1. Whereas delta reactants, change in reactants is equal to R2 minus R1. Whereas change in products, that is delta P, is equal to P2 minus P1. So overall, how in time delta T, how the reactants and products are changing will be indicated in this way. This is going to be rate of reaction, how it is going to change. For that one, we have to know how the changes are going to be indicated, right? And now we are going to discuss about rate of reaction in a detailed way. So rate of reaction is equal to change of concentration with respect to time is called as change. We can call it as delta D. If it is small, you can call it as D concentration by dt. So if you are taking a reactant to product, how the rate can be indicated in two ways. One way with respect to reactants, one way with respect to products. So with respect to reactants, the decrease in the concentration of reactants, decrease in the concentration of reactants by time, change in time. In the same way, increase in the concentration of time, increase in the concentration of reactants, increase in the concentration of reactant with respect to time is called as a rate of reaction. That is means here change in time. We can call it as change in time. Decrease in the concentration of reactant, how the reactant is changing in some time. In the same way, how the products are changing with respect to increase in the concentration of product. Increase in the concentration of product or decrease in the concentration of reactant is going to be the rate of the reaction. Rate of reaction. Here, if you are taking how reactants are going to change into products with respect to time is going to be rate. Rate is equal to change in concentration of either reactants and products to the time taken. For example, this can be expressed in terms of two ways. One with respect to reactants, other one with respect to products. Imagine reactants. What happens if the reaction proceeds from left to right? What happens? Reactants concentration will reduce. Obviously, without reducing concentration of a reactant, product will not be produced. The concentration of reactant will come down, whereas the concentration of product will go up. So we can express the rate of reaction in two ways. With respect to reactant, if you are taking the concentration of reactant is going to be reduced, that means decreasing the concentration of reactant with time taken. That is going to be rate. That is going to be rate. This is with respect to reactants. With respect to products also we can call it as rate is equal to increase in the concentration of product by time taken. That means here the rate can be expressed in two ways. One, decrease in the concentration of reactant is what? Obviously, it is going to be concentration will be expressed in terms of concentration expressed in terms of already we have discussed mole per liter. That will be indicated in brackets. So, rate of change of concentration with respect to time is called as a rate here. Same way, change of concentration of product. Here concentration of product is indicated with a bracket P by dt. Right? Here very important point is decrease in the concentration of reactant. Whereas in case of products, it's going to be increase in the concentration of products. So this negative and positive are just a symbols which indicates that negative means decrease in the concentration, positive means increase in the concentration. So in this way, we can define a rate of a reaction. Rate of a reaction. Now let us look into the variation of concentration with time. Already we have discussed that only. With time, how the concentration is varying, that is called as rate. Now let us look into the change of concentration with time with a different examples. Let us take an example to express the variation of concentration with time. Variation of concentration with time. First, let me take a general example. A plus BB gives rise to CC plus DD. This small A, B, C, D are going to be coefficients, whereas A and B are reactants, C and D are products. Here, if you are considering rate, here it is going to be disappearance of reactant with respect to time. That is time taken. How to express? We can express rate is equal to minus 1 by A into delta A by delta T. Here, delta A is change in concentration of A with respect to T. Same way, minus 1 by B is equal to delta concentration of B by delta T. So, this is with respect to reactants. These negative signs are going to indicate that decrease in the concentration of reactants. The same way, rate can also be expressed in terms of change of concentration of products. These are reactants, right? Appearance of products. What is appearance? That means increase of concentration. We can call it as appearance also. Time taken. Here we can call it as or decrease. Decrease in the concentration of reactant. Here we can call it as or increase in the concentration of product. Increase in concentration of product. Decrease in the concentration of reactant with respect to time or increase in the concentration of product. What are our products? Our products are 1 by C into delta concentration of C by delta T is equal to 1 by D delta concentration of D by delta T. Here, very important thing is as both are rate equations, we can also call it as therefore minus 1 by A by delta T is equal to minus 1 by B delta B by delta T is equal to 1 by C. Here we can see minus for reactants and plus whether it is writing or not same 1 by C, that is small c into delta C by delta T. This must have a concentration. This must have concentration and it is going to be 1 by D delta D by delta T. So, this is what variation of concentration with time. Here we can see concentration vary with time. Concentration vary with time. So, these with respect to reactants, this is with respect to products. In the end, we can make equal also because here you can see these are with respect to reactants products together. Whether that is decreasing the concentration of reactant or decreasing the concentration of second reactant or increasing the concentration of product or increasing the concentration of other product, all are in the equal only. That is what variation of concentration with respect to time. If you are taking some example, one more example, N2 plus 3H2 gives rise to 2NH3. If someone asked you to write a rate of a reaction for this one, then it is going to be a rate is equal to, it is very clear to see that N2 plus 3H2 gives us to 2NH3, right? N2 means delta N2 divided by delta T is equal to minus 1 by 3 concentration of H2 divided by delta T is equal to plus we can write it as plus 1 by 2 concentration of ammonia divided by delta T. So, in this way we can write any rate of a reaction for any reactions. And now we are going to discuss about rate loss and rate constant. Here we are going to discuss about rate loss or rate expression. Now, how the rate is related to concentration of reactants. How the rate is related to concentration of reactants is called as a rate law. Now we are going to discuss about how rate is related to reactants in a general way. For example, if you are taking an equation called AA plus BB gives rise to CC plus DD. Here, for example, if the rate is depending on the concentration of reactant and concentration of product to some powers, these powers may or may not be equal to these coefficients. These coefficients don't have any role with respect to the concentration powers. Here, if you are looking carefully here, rate is proportional to concentration of A and concentration of B and concentration of A with respect to power X, concentration of B with the power Y. Here X and Y are powers of concentration A and concentration B respectively, but they are may or may not be equal to A and B. This is what rate expression is. Here X is equal to order of A, Y is equal to order of B. This order we will discuss later. So, this rate of the reaction cannot be expressed by looking at the reaction directly. A point should be very clear here. Rate of the reaction means rate loss or rate expression cannot be expressed by looking at the reaction. This is cannot be identified by theory. From theory we cannot get this one surely from the experiment. From the experiment only we have to write this rate of the reaction because we don't know how much power it is going to be. So, how to identify rate law or rate expression? Here, if you are looking carefully here, this rate is proportional to concentration of A and concentration of B. So, this can be expressed in this way also. Rate is equal to some K into concentration of A to the power X, concentration of B to the power Y. Here K is called rate constant. K is called rate constant. So, here rate law means how the rate is linked to concentration of reactants is indicated in rate law or rate expression, which here you can see rate is equal to K into concentration of A power X and concentration of B. In the same way, here K is called as a rate constant. Here the same way we can express in terms of differential way also. This is a normal reaction minus dx by dt, that is dx by dt means what? Rate. Rate is equal to dx by dt is equal to some K into concentration of A power X and concentration of B power X Y. Here rate law can be expressed in this way. Now rate law, in this one we have discussed that rate of reaction is proportional to concentration of A and concentration of B with power X and Y. This X and Y are going to be orders with respect to A and B respectively. The same reaction we can express in terms of for example, rate of reaction is equal to some K into concentration of A power X, concentration of B power Y. Here K is equal to rate constant. and A and B are reactants, that expression of rate of reaction with respect to concentration of reactants is called rate law or rate expression. K is rate constant. The same rate of equation can be expressed in terms of differentiation also. Decrease in the concentration of reactants is equal to minus dr by dt is equal to K into concentration of X, concentration of Y. Same thing, this one and this one are same. This one we have expressed in terms of rate of equation and this one in terms of derivative. So it is called differential rate law. Otherwise, rate law in terms of differentiation, right? So here, if you are looking carefully here, this K that means rate is equal to K into concentration of A into concentration of B power X and Y. Here, if you are taking the concentration of A as 1 unit, that is 1 mole per liter, and concentration of B is equal to 1 mole per liter, then what happens? Your rate of reaction is equal to K, because 1 into 1, that means K. So, rate constant can be defined as rate constant is the rate of reaction when concentration of A and concentration of B are unity or 1 unit. So, rate of reaction is equal to rate constant when concentration of reactants are equal to 1. And exactly at this condition, rate constant is called as rate constant at concentration of A and concentration of B is equal to 1 is called as specific reaction rate. Specific reaction rate, because here this is rate, right? At specifically, if you are mentioning, that is called as specific reaction rate, that is at unity 1. So, what is this rate constant? The rate constant is the proportionality constant which is not depending upon the concentration, but which depends upon temperature and pressure. Rate constant is the one which depends on pressure and temperature but not on the concentration term. Whereas if you are looking into the specific reaction rate, right? Specific reaction rate is also a rate constant exactly when concentration of B and concentration of A are equal to 1. That time your rate will be equal to rate constant. This rate constant, when it is exactly equal to rate of reaction, it is called as specific reaction rate. So, we have finished specific reaction rate, rate loss, variation of concentration of time, rate of reaction and introduction to chemical kinetics.